Welcome back. This is video 3. We got 20 more slides to cover, so let's see if we knew it in this 10 minutes, 30 seconds per slide. Okay, ocean and tidal power, there's several types. Tidal power harnesses potential energy from building structures across an estuary. We're going to have a picture of this. This is done in France, along with tidal currents. Harnessing the kinetic energy of currents using modular systems. We'll see a picture of this later. Wave power is just using the wave energy, the motion of the wave to generate energy. Temperature gradients, if anyone has ever gone scuba diving, you realize that there is a severe temperature gradient in the ocean, especially around 60 feet. So you use this like you would hydrothermal power to create energy. And then salinity gradients, it's the same thing, but using the salinity from mouths of river where freshwater and saltwater mix. So facts about the ocean and tidal water, there's lots of potential for technology, but none are in widespread use. So there might be some around the world, but they're not in widespread use. Okay, but few that are producing power at a substantial level. There are a lot of prototypes in the world. Lots of academic studies to calculate effectiveness and proof of concept. It's still in the development stage. It has not been proven. So area per traditional tidal power. Alaska, you get Canada, you get the northeast of the U.S., Europe, northeastern England, things like that. They're just there. There are severe tides that warrant the application of tidal power. So types of ocean powers, this is a buoy method. There's a float with a heavy plate on the bottom. When it rotates, it generates current. There's an undersea substation pod, and then the cable generates power back. This is the same thing with the land. This is for tides, if I can spell. It's just a tide gate or barge that it uses the water coming in to going out to turn this turbine to create electricity. And then you have a closed cycle system. This is talking about that pressure gradient or temperature gradient, cold water and then hot at the top, spins a turbine, comes back down, condenses, cold and then hot once again. So here we go. Wave power. There's a bunch of different methods that a lot of people have proposed. So this is a balloon or a float type. And it rotates this base that produces electricity. These are under the water, so it's not technically aesthetically displeasing. The energy turns turbine, it creates a plant, or it can desalinate, and this one creates fresh water. Ocean, this is, what are they called? The wave type device. Oh no, I'm sorry. Wave type device. There's a couple different designs that if you want to look to more, you can certainly find YouTube videos and especially a lot of research papers on each of these types. They each have their merits, their advantages and disadvantages. More technologies. This is just a giant wind turbine underwater, and these are the same things with buoys offshores, and this is 1 to 2 miles offshore. It's a relatively simple concept. You're moving a rod in a permanent magnet around electrical coil to produce electricity. Then this one has the same principles as a wind turbine, but is for the water. Even more technologies. This is the oyster wave energy converter. It rotates this back and forth to create energy. We talked about this earlier with the heat exchange, pressure, cold water, hot water, that it turns this turbine. Sea turbines, it's not the most efficient. It's not the most. It changes. It depends. That's a hard answer, but it depends. Okay. Some power equations for wind turbine can be converted to water, but salt water flowing, the way that it interacts with the blades is different than wind. So you have to take that into account. And then you have things to worry about like salinity. What if you hit a log in the water, something floating, or a blue whale? Still like that, but your limitations are there. Tidal barges. This is used in France. I think we have a picture coming up here in a second. the next slide, I believe, but it spans a river or the mouth of a river with a turbine in between, and it spins the turbine underwater when the tide goes in and out, like this picture. Yep, here we go. So the tide comes in or out, and this is just a bridge, so traffic can go past. And what it does is it spins a turbine and then thus produces electricity at super cheap 3 cents a kilowatt hour. The bridge is 330 meters long, and the tide ranges plus or minus 8 meters. So that makes sense, right? You're harnessing the power of the moon, changing the tides of the ocean, and converting it into energy at really cheap, and you get a bridge out of the deal. Advantages and disadvantages of ocean powers. Once it's built, it's nearly free unless you have maintenance costs because things corrode in salt water. Tides are predictable, especially on the East Coast. I live in a tidal region, and I could tell you when I'm home the tides. We have a tide clock because high tide's relatively important. They're relatively low maintenance. It's like a hydroelectric dam. Water flows, the turbine spins, it's there. And they're out of sight. No one really sees this. That's one of the benefits, especially like that bridge in France. It just looks like a bridge, right? But they're generating electricity out of this sucker. Okay, disadvantages. Tidal system works about 10 hours a day when the tides are moving. It's not that on-demand that we were talking about with dams. The distance from the shore and the power users changes. They're not necessarily correlated. We talked about that in correlations that you try to make in lecture 1. Waves change and suitable sites may be rare. This mouth in the river in France may not work in, let's say, the Chesapeake Bay, right? The mouth of the Chesapeake Bay is pretty large. It's not going to probably work there. And it must stand up to rough weather. This would have to survive like a Katrina event or something like that. Do you impact the habitat? Some systems are noisy. Does it affect the ecosystem? Does it affect military radar, sonar, things like that? All things to consider. So geothermal power, we're just going to touch on it real quick. Uses heat generated and stored in the earth. It's reliable, cost-effective, sustainable, and environmentally friendly. It's just using that higher and low pressure or temperature gradient. So some fun facts about geothermal. It was introduced in 1904 in Italy. First successful plant was in geysers in California. 10.7 gigawatts installed capacity worldwide. 3 gigawatts in the U.S. Woot woot. Philippines gets 27% of their electrical power from geothermal, which is quite a bit. Worldwide generation was 67.2 terawatt hours in 2010, up 20% from the last 5 years, and it's expected to grow. So geothermal potential, we were talking about solar potential in the United States, and the same thing with geothermal. It's where the volcanoes or volcanic hotspots kind of are. So we're looking mainly at the West Coast. In the areas, so power plants, and then direct uses would be like home heating and things like that. In areas, you need the right geological conditions to have a geothermal potential. Come on. Direct use, produce heating from hot water within the earth. You can heat a home, you can heat hot water. Electrical production uses the heat using a steam turbine method. You turn the turbine, produce electricity. Heat pumps uses earth's shallow ground temperatures for heating and cooling, household things, large scale, small scale, it doesn't really matter. This is in Boise, Idaho. It's the largest direct use of United States supply efficiency, over 55 businesses and homes. Virginia Tech has this, but we don't use geothermal. We use the heat coming off the power plant, the steam energy to heat all the dorm buildings and residential buildings, but it now injects 100% of the water back into the aquifer. There's no water used during the process. Geothermal technologies, there's a dry steam, there's various methods that you use to talk about, but we're going to have to go into another video here because we are running out of time. So I'll be back in a second.